All right, today we're going to tackle a really simple question that has a surprisingly awesome answer. How many different ways can you actually unfold a cube? Trust me, it's a super cool geometric puzzle, and we're going to solve it right now. Okay, let's jump right in. We all know what a cube is, right? But have you ever really stopped to think about how it's made? I mean, every single box, every pair of dice, it all starts out as one single flat piece of material. The real trick, the real puzzle, is figuring out which flat patterns will actually fold up into that perfect little cube. So this is the big question. A cube has 6 square faces. So how many unique ways can you arrange those 6 squares so that they can fold back up into a cube? Go ahead, take a guess right now. You think it's 5? 10? Maybe 20? Let's find out together. Now, before we just start slapping squares together, we've got to lay down some ground rules. Because, as you're about to see, not just any old arrangement of 6 squares is going to work. There are a few key things to keep in mind. So in the world of geometry, these foldable patterns actually have a name. They're called nets. So what we're really looking for are cube nets. Think of it like a perfect 2D blueprint for a 3D cube, one that folds up perfectly with no gaps and no bits overlapping. So this is super important. Any shape we come up with has to follow 3 simple rules. Rule 1, it's got to have exactly 6 squares. No more, no less. Rule 2, all 6 of those squares have to be connected, edge to edge. No floating pieces. And rule 3, this is the tricky one, when you fold it, none of the squares can land on top of each other. All right, we've got our rules, so now the fun part begins, the hunt. We can actually start to figure these out just by trying a few different arrangements in a logical way. To do this right, we can't just guess randomly. We need a system. So a great place to start is with what I like to call a backbone of 4 squares all in a straight line. Now all we have to do is figure out where the last 2 squares can go. So check this out. If we stick the other 2 squares on opposite sides of our backbone, we get this classic cross shape. You can totally picture that 4-square spine wrapping around to make the sides, and then the other 2 pop on as the top and bottom. Perfect! Or what if we put them on the same side, like this? We get this T-shape. That also folds into a perfect cube. Hey, that's 2 down already. Now you might be thinking, okay, just stick 6 squares together and you're good to go. But not so fast. We have to be on the lookout for imposters. These are shapes that look like they should work, but they just don't. Which brings up a really important question. Does any old arrangement of 6 connected squares actually fold into a cube? Well, let's look at one that seems like it should work. Take a look at this guy. It follows our first 2 rules. It has 6 squares, and yep, they're all connected. It's even got that 4-square backbone we were just using. But when you actually try to fold it, yeah, something goes very, very wrong. And here's why it's a total fake. As you fold up the sides, you see these 2 squares right here? They're on a collision course. They both try to become the top of the box, and they land right on top of each other. And because of that overlap, you're left with this gaping hole where the bottom of the cube should be. So nope, this imposter is definitely not a valid net. Okay, so now we get it. We know the rules, we know how to spot the fakes. Now that we know what we're doing, we are ready for the big reveal. Just how many unique ways are there to unfold a cube? The answer is 11. That's it. After all of that, there are only 11 unique 2D patterns that can be folded into a perfect cube. Kind of cool, right? And here they are in all their glory, the whole family. Every single one of these colorful shapes is a totally valid net. It's amazing how different they all look. But wait a second, if you count them up, 1, 2, 3, there are only 10 shapes here. What's going on? Well, turns out one of the most common nets is actually missing from the photo. It's that T-shape we found earlier. See that little blue cube sitting there? It's basically a stand-in for our missing 11th net. It's just a funny little reminder that even when you're playing around with math, sometimes you misplace things. So we solved the main puzzle, we found all 11 nets, but when you look at them all laid out like this, you start to wonder, is there anything else these 11 totally different shapes have in common? Let's dig into something kind of weird, their perimeter. The total length of the outside edge. Let's start with that classic cross shape. If we say that each side of a square is just 1 unit long, what's the total distance all the way around the outside? If you count it up,
The perimeter is 14 units. Simple enough, but a totally different looking shape has to have a different perimeter, right? I mean, that just makes sense.
Well, let's put that to the test. Let's grab one of the more unusual ones, this zigzag shape here. Visually, it looks nothing like the cross. So what do you think? What's its perimeter? It's also 14 units. Exactly. The same. Whoa, how is that even possible? How can two shapes that look so incredibly different have the exact same perimeter? So what's the deal here? Was that just a crazy coincidence that those two had the same perimeter? Or could it be that all 11 of these unique CubeNets share this exact same property? Now that is a pretty cool final puzzle for you to unfold.